Assalamu alaikum, students. Today we are going to start solving a past paper of A-level mechanics, which is called paper 4, and normally we say mechanics 1 or M1. Okay, the M1 has code 97094 and paper 4 and 2 is the variant. You could have 4-1 or for 3 as well, but this code is for you for 2 for the Asian zone. Paper mechanics M1 have the time 1 hour 15 minutes and its total marks are 50 and the formula list F9, there are a few formulas given in the formula list which will be provided in the exam to you. And the question paper, you have to answer correct to three significant figures, the numeral answers. And if it is the angle in degrees, you have to provide your answer to one decimal place. Acceleration due to gravity, you have to use 10 meter per second square. And rest is, the same. You can use the electronic calculator with that. Okay, we'll come up with the next question. This is the question number one of we are going to solve the past paper May June 2017. This is variant 2 May June 2017 again. Okay, so this is question number one. In the question number one, first of all, we'll read the question and we'll try to understand what is given to you and what you need to find out. On one end of a light and extensible string is attached to a block. Okay, the string makes an angle of theta degree. Okay, if I make a block like this is a block, and this is the string which is making an angle of theta degree with the horizontal. Okay, the string is makes an angle of theta degree with the horizontal. The tension in the string is 20 Newton. So we'll write down 20 Newton. So best way to solve the word problem is that you go along with the statement. Whatever is given to you, you should start writing down, start jotting down the information whatever is given, and at the end you reach so that you can reach the answer easily. Okay, this is what is given to you till here 20 Newton. The tension in the string is 20 Newton. The string pulls the block along a horizontal surface at a constant speed of 1.5 meter per second. So we'll highlight this because this is really very important. That means the system is in equilibrium, the acceleration is zero, and because of the speed is constant for 12 seconds. So that means you are given the speed and the time. So we'll write down speed v is equal to 1.5 meter per second, and time is given 12 seconds. Okay, the work done by the tension in the string is 50 joules. Okay, work done by the tension. That means this is the work done by the driving force. Work done by driving force is equal to 50 joules. Okay, so now you know that we have to find out. Okay, we have to find out theta. So we'll write down theta is to find out. Okay, now you know that the speed is constant. So s is equal to distance is equal to speed into time. So what is the distance covered by the object? So that is distance is equal to 1.5 into 12 seconds. So that is meters. So total distance covered with this speed in 12 seconds is 18 meters. So distance is equal to 18 meters. Okay, you know that the work done is equal to driving force into work done by the driving force will be equal to work done by driving force is equal to driving force into distance, and this is 50 joules. And what is the driving force? Here, the driving force, if you find out its horizontal component, so this is the vertical component, this will be here in this one, and this one, if you find out its horizontal component and vertical component, this is 20 cos of theta, and this is 20 sine of theta, right? Okay, so driving force is 20 cos of theta into 18. So cos of theta is equal to 50 divided by 20 into 18. So theta is equal to cos inverse, that will be 50 over 360, that is equal to theta is equal to, you got cos inverse by using calculator, you can find out 82.0 degree is the theta you are supposed to find out. Hope you have understood the concept. Okay, this is the distance covered and this is the angle theta which we were supposed to find out. Okay, the next question. The next question is question number 2. In this question, the diagram, if we'll read the question first, we'll try to understand what is given to you and what you need to find out. Okay, in the first, the diagram shows a wire ABCD consisting of a straight part AB, the length AB, part AB of length 5 meter. Okay, the part BCD in the shape of a semicircle with radius 6 meter and center O. That means this is the semicircle and this is the radius, the diameter, and this is the radius. So this would also be 6 meter and this would also be 6 meter. Okay, so the diameter BD of the semicircle is horizontal and AB is vertical. This is vertical and this is horizontal. That means it's making 90-degree angle with that. Okay. A small ring is threaded onto the wire and slides along the wire. From here, a ring is, you know, slided and it comes to at B. The ring starts from rest at A. So that means at A, the velocity is equal to 0 meter per second, right? Velocity of the ring at A is 0 meter per second. And the part AB of the wire is rough and the ring decelerates. Due to roughness, the ring decelerates at a constant rate of 2.5 meter per second square. Now you are given the deceleration, so you can highlight this. This is so A is equal to minus 2.5 meter per second square. So you are given the deceleration, right, between A and B. Show that the speed of the ring as it reaches B is 5 meter per second. Okay, there is distance involved, s is equal to 5 meters, initial speed 5 meters, initial speed is given to you, that is 0 meter per second, and you're supposed to find out the velocity at B, velocity at B, speed of the ring at B. Okay, we have to find out the final velocity. So these A, V, U, A, and S comes in the formula V square is equal to U square plus 2AS. So what we'll do, we'll substitute the values. V is equal to square root of 0 square plus 2 into minus 2.5 into, sorry, this was acceleration. Sorry, I'm really sorry for that. This was acceleration 2.5 uh, to AS. So this is 5 meters. Okay. So we'll get V is equal to 5 meter per second. 5 meter per second. So you are supposed to show that the velocity, final velocity is 5 meter per second. So that was acceleration. I'm really sorry for that. I thought this is deceleration. Okay, so you have shown what you were supposed to. Okay, in the next part, they are saying we might need the we might need the diagram. So I'll copy the diagram and paste it below. Okay, so let me copy it down. Okay, I'll paste it here. Okay, now they are saying the part BCD of the wire is smooth. So this part is smooth, right? Okay, the mass of the ring is 0.2 kg, and find the speed of the ring at C, where BOC is 30 degree. So what we are going to do, we'll find out the height. Actually, as this path is smooth, so whatever potential energy at B would be converted into kinetic energy, change in kinetic energy at C, right? So we will be finding out its height first. So height is, come on, okay, G. Sorry, there is some problem in the, okay, we'll draw the perpendicular distance. This is, so we'll find out height. And what is height equals to? So we'll use sine to sine of 30 degree. Sine of 30 degree is equal to perpendicular over hypotenuse, which is 6. And you'll get h is equal to 6 times sine 30. And you know that sine 30 is 1 by 2. So it will become h is equal to 3 meters. You got h is equal to 3 meters, right? Okay, now potential energy at B will be converted into change in kinetic energy at C. Kinetic energy at C. Okay, so potential energy is mgh. Kinetic energy, change in kinetic energy is half mv square minus u square. And u here, that would be at B. The velocity, we proved that the velocity was 5 meter per second at B. So initial velocity at B is 5 meter per second, and at C, V we have to find out, right? At C, V meter per second we have to find out. Okay, M cancel because that's the this is there's one fraction on both sides. You can cancel it. And what is G? G is 10. Sorry, 10 into height is 3 is equal to 1 by 2 into V square minus 5 square. Okay, so this will become 30 and 60, V square minus 25, V square minus 25 is equal to 60. V is equal to square root of 85. And use your calculator to find out the square root of 85. That will be V is equal to, this is 9.92 meter per second. So we found that the velocity of the object of the ring at C will be 9.92 meter per second. Okay, the next, find the greatest speed of the ring. So greatest speed of the ring will, again, I'll copy it down here, paste it here, the diagram. Okay, so this is the point, this is the point where the speed of the ring will be maximum at the bottom of the curve, at the bottom of the semicircle, at the bottom of when it reaches to here, the speed will become maximum and then it will start decelerating, and at D it will be different. Speed would be different. Okay. Now we'll find out what is the height. This height would be 6 meter because this is the radius of the uh, semicircle. So what happens here, that the potential energy at B will be equal to change in the previous formula as we used in the previous one, change in kinetic energy. Okay, so what is potential energy at B now? mgh is equal to half mv square minus u square. So you know that at B the velocity was 5 meter per second, 5 meter per second. Now we have to find out here v meter per second. So m cancel. This is 10 times 6 is equal to 1 by 2 into v square minus 5 square. So this will become v square minus 25 is equal to 120. So v square is equal to square root of 145, and if you use your calculator, this will be v square is equal to 12.0 something. So that will be counted as the three significant. If you round it to three significant figures, it would be your answer. 12.0 meter per second will be the final velocity. This is the greatest velocity the object can achieve at the bottom of the semicircle. Hope you have understood the concept. Okay, the next question is question number 3. I'll try to finish this paper in this video, and so this is the reason I'm doing some hurry. Okay, sorry. Okay, in question number 3, so we'll read the question first. A particle moves in a straight line with a constant speed of 10 meter per second. So what you have to do, you have to highlight whatever is given to you. So this is the constant speed of 10 meter per second. A particle moves in a straight line, a particle A. So 2 seconds after 2 seconds after A passes the point O on the line, a particle B passes through O. That means the difference between the time of A and B is 2 seconds. Moving along the line in the same direction as A, particle B has speed of 16 meter per second at O and has a constant deceleration of 2 meter per second square. Find the expression in terms of t for the displacement. We have to find out displacement from O of each particle t seconds after B passes through. That means this time t seconds is for B. So if the uh, time for B is t seconds, so B is t seconds. If B has t seconds time, That means A will have the time t plus 2 seconds, right? This is time for B, and this is time for A. Okay, now they are saying find an expression for the displacement. So displacement as A is moving with a constant speed. So for the constant speed, you know that this is speed into time. So displacement of A, that will be equal to speed into time, that is speed into time. So it would be, let's save the page, 10 times t plus 2, right? So this is so S displacement of A in terms of t is 10t plus 20 meters. Okay, now what is S of displacement of B, as this is decelerating acceleration and the initial velocity is involved. So what is the initial velocity for B? For B, the initial velocity is given u is equal to 16 meter per second and A is equal to minus 2 meter per second square, and time is equal to t seconds, and you have to find out displacement. So you'll find out in which formula is appropriate for this. So this is S is equal to ut plus half at square. S is equal to ut plus half at square. So we'll substitute here. S of B is equal to 16t plus half into minus 2, and this is t square. So this displacement of B is equal to 16t minus t square, so meters. So these are the two displacements in terms of t we have found for the part 1. Hope you have understood the concept. There is no issue, no problem in doing it. Okay, second part, they are saying find the difference between the particles when B comes to instantaneous rest. So instantaneous rest means, what does mean by instantaneous rest? That means velocity becomes to zero, 0 meter per second. So we have a displacement of B. What is S of B? That is equal to 16t minus t square. So we'll find out the velocity. You know that velocity is equal to derivative of displacement with respect to time, change in displacement with respect to time. So V is equal to 16 minus 2t. So as we have to find out at what time the velocity will be 0. So we'll take velocity equals to 0, 16 minus 2t, and t is equal to 8 seconds. So we found that at t is equal to 8 seconds, the velocity will become 0. That means the particle B will become at instantaneous rest. So we'll find out the difference between their displacements. What is the difference between their displacements? S of A minus S of B is the difference between the displacements. So this would be S of A, sorry, this is S of A is 10t plus 20, and that is S of B is 16t minus t square. So S of A minus S of B is equal to 10t minus 16t, that will become t square, and minus 6t plus 20, that will be the distance difference between the displacements of the particles, right? Okay, so let me highlight this first. Okay, we'll find out the difference between the displacement at t is equal to 8 seconds, because at t is equal to 8 seconds, the particle B will become at rest, and we want to find out at that time when the particle B is stopped, is have becomes to rest. So what was the difference between the time? So t is equal to 8 seconds. Substitute that. Okay, S of A minus S of B is equal to 8 square minus 6 into 8 plus 20. So the displacement is S of A minus S of B. Okay, let me use the calculator. This is 64 minus 48 plus 20. So this is 36, 64, 36 meters. So 36 meters. So you got the distance between the particles when the B stops, that is 36 meters. Okay, next is in the next third one, part 3, find the minimum distance between the particles. We have to find out the minimum distance between the particles. Again, we'll move back. What is the difference between the particles? So that is SA minus SB is equal to T square minus 6T plus 20. Okay, so this is the distance. So if I say S is the displacement between the two particles, SA minus SB, so T square minus 6T plus 20. So T square minus 6T plus 20 is a quadratic equation. This is it's a quadratic expression, and its graph would be like this. So this would be the minimum point. The minimum point will be the minimum at this point. This displacement will be minimum. So we'll find out what is the value of t at this point. So you know that if you draw the tangent at this point, that will be equal to 0. So that means ds over dt as at this point will be gradient of the tangent will be equal to 0. So we'll find out ds over dt is equal to 2t minus 6, and this is 0 is equal to 2t minus 6, and t is equal to 3, and that means at t is equal to 3, the difference between the particles will be the minimum. So at t is equal to 3, SA minus SB is equal to t square minus 6t plus 20. So that would be the difference between the displacement of A and B, 3 square minus 6 into 3 plus 20. So this will become 9 minus 18 minus 9, and this will be 11 meters. So the minimum displacement between the particles A and B will be 11 meters. Hope you have understood the concept and the question. Uh, so we'll move to the next question, question number 4. In this question, what we are going to do, we'll do the same as I told you before, that we'll start reading the question and we'll jot down what is given to you and what is need to find out. Okay, a car of mass 1200 kg moving in a straight road against a constant force of 850 Newton resisting the motion. So you are given two things. This is the uh, mass, and this is the resistance force. So we'll write down M is equal to 1200 kg, and you're given that Fr is equal to 850 Newton. right? Now, part 1, on a part of the road that is horizontal. This is horizontal, straight like this. Okay, the car moves with a constant speed. So highlight this constant speed. That means the acceleration is zero. A is equal to 0 meter per second square. So calculate in kW the kilowatt, the power developed by the engine of the car. So we'll find out the driving force and we'll multiply by the constants, because power of the engine is equal to driving force into velocity. We don't have the driving force at the moment. So you know that driving force minus resistance force is equal to force net, MA. So what is the driving force? We have to find out. Resistance force is 850 Newton, and M 1200 into acceleration is 0. So that means FD will become, driving force will become 850 Newton in this case when it is moving with a constant speed. Due to speed is constant, the driving force and the resistance force will be equal as acceleration. There is no acceleration. So power is equal to driving force into velocity. So power of the engine is equal to 850 into 42 watts. Initially it would be watts, so that would be 357,35700 watts. And if you change it into, so you have to divide it by 1000. So this will become power is equal to 35.7 kilowatt. Okay, in the part B, given that the power of the power is suddenly increased by 6 kilowatt, find the instantaneous acceleration of the car. So what we are going to do, will add this 6 kilowatt in the power, this one, right, in watts. So power will become 35.7 plus 6 kilowatts. So this will become 41.7 kilowatt. This is power is equal to 41700 watts. Okay, you know that power is force driving into velocity is equal to 41,700, as velocity is not changed. So initial velocity instance when this is increased, at that time initial velocity will be 42, and after that it will start increasing. So this will become 41700, and driving force will become equals to, if you divide it 42 on the other side, this will become 992.86 Newton. So you got, this is the driving force now. When the this is increased 6 kilowatt, at that instance, the initial velocity was 42 meter per second. After that, it will start accelerating. Okay, so FD minus driving force minus resistance force is equal to force net MA. So 992.86 minus 850 newtons is equal to 1200 into A. So we'll find out A is equal to, this will be 992.86 minus 850 over 1200. So do use the calculator. So we'll use the calculator. Okay, let me give a, let me a second please. Okay, so this is 0.119 meter per second square. So you got the acceleration equals to this one. This is, hope you have understood the concept. At the beginning, when the force is increased, at that time the velocity will be 42, so that will be initial velocity. So that's why we have used the velocity 42 here, and then after that the velocity will be increased and it will be start accelerating. Okay, in the next part, this is on a part of the road, that is inclined to theta at theta degree to the horizontal. So if, okay, just wait, there's some problem. Come on. Okay, this is the inclined surface. Sorry, this is the inclined surface with theta degree. There is the object. Okay, its weight is mg. So m is that is 1200 kg. So mg, which is 1200 into 12,000 Newton. Okay, so this is the R, normal contact force, and this is theta. This is the vertical component, which is mg cos of theta. So this is 12,000 cos of theta. And this is the horizontal component. This is mg sine of theta. This is 12,000 sine of theta. Right. Okay. And constant resistance force, which is resisting the motion, that is because the motion is on this side, motion is upwards. This is the motion. Okay. And so 850 Newton, the constant force resisting the motion is over there. And this is called the resistance, which was constant. And this is due to inclination. This is the resistance force due to inclination of the, inclined surface. Okay, they are saying the car moves up the hill at a constant speed. Now, this is really very important. Constant speed, that means there is no acceleration. So FD is equal to that. That means acceleration is zero. So we'll write down acceleration is zero at this time. So this is the important information. Okay. Now, with the engine working at 80 kilowatt, 80 kilowatt means power of the engine is 80 kilowatt. That means 80,000 watts, right? Now, power is driving force into velocity is equal to 80,000. So, driving force into what is velocity? Velocity is 24 is equal to 80,000. Okay, driving force is equal to what? That is 80,000 divided by 24. So this will come 3333.3 Newton. So you got the driving force equals to 3,333.3 Newton. Okay, now we know that FD driving force minus resistance force is equal to force net, that is MA. So driving force is 3,333.3 minus resistance force is R2. One is this one, which is 12, sorry, so 12,000 sine of theta plus 850 is equal to 1200 into 0. So this will become 3333.3 minus 12,000 sine theta minus 850 is equal to 0. So 12,000 sine theta is equal to, so sine theta is equal to 3. I'll do the calculation uh, overall, because doing calculation again and again, I have to stop writing for that. Okay, so if you divide it, so you'll get sine theta is equal to 0.2069 and theta is equal to sine inverse 0.2069 and theta is equal to 11.9 degree. So you got the angle at which the surface is inclined. Okay, so hope you have understood the concept and you have got everything. Okay, let me highlight, this is the resistance force. This is the resistance force which are working in this direction, while the motion is upwards. The force which is working in this direction is driving force. So driving force minus sum of this resistance force, and this is also the resistance force, that is equal to force net. As the speed is constant, so acceleration is 0. So we'll substitute acceleration 0 here. So ma will become 0. That means Fd minus Fr is equal to 0. Okay, hope you have understood the concept. So come to the next question. This is question number 5. Okay, we'll read the question first. This is really very important question. It's a very good question. Okay, in this question, you are given one inclined surface, and there's a particle P or particle on the inclined surface, and a force of P Newton is applied on the particle at an angle of 30 degree. Okay, let's read the question first. A particle of mass 0.12 kg is placed on a plane which is inclined at an angle of 40 degree to the horizontal. The particle is kept in equilibrium. This is really very important. The particle is in equilibrium. That means it's not moving. Okay, by a force of magnitude P Newton acting up the plane at an angle of 30 degree. Okay, above a line of greatest slope, as shown in the diagram, the coefficient of friction is also given, that is 0.32. Find the set of possible values of P. Okay, so there would be two things. So first of all, we have to understand this situation very clearly. There are two things, two in surface angles. So we have to find out the horizontal and vertical components of these two. This is mg. So what is this mg? M is mass is 0.12. So this will become 1.2 Newton. Okay, this is the vertical component, and this is the normal contact force of the object. So this is the vertical component and this is the horizontal component. This angle is 40 degree. So this is 1.2 cos of 40 degree, and this is 1.2 sine of 40 degree. Sine of 40 degree. Okay, above I'll make it some bigger, because so that I can differentiate between these two. This will become P cos of 30 degree. This is the horizontal component, and its vertical component will be P sine of 30, that is upwards. Okay, so you got these forces. These are the forces. This is upwards and downwards, and in this direction and in this direction. Okay, so if you draw a box, I think I should draw the box. That is, we'll use a little place to draw the box. Okay, try to spend less. Okay, we have a lot of space, no problem. Okay, I'll draw a box here. In the box, I'll identify the all the forces. This is normal contact force upwards. Upwards, this is P sine of 30, and this is to this side, this is P cos of 30, and this is downwards is 1.2 cos of 40, and in this direction, this is 1.2 sine of 40. 1.2 sine of 40 degree. Okay. Now they are saying find the possible set of possible values of P. Set means there would be, this in the inequality. That means now from lowest to highest value of P. Okay, there are two things which we have to understand very carefully. So, if this force is enough for this to make it a point that it is to move upwards, it is to move. Let the power P is enough that this particle or this particle A is at the point which it is to move upwards. So when that means at that time its direction of motion is towards this side, the friction will work in the opposite direction. So this would be the first. Okay, let me copy it down first because I have to make it again for. Okay, okay, so this is the first. uh, this is the first, uh, you can say, option, that it is to move upwards. It is at the point where it is to move upwards, so the friction always works in the opposite direction. So friction will work in the opposite direction. Okay, now let's wait. Sorry. Oh my god, I have to copy it again. Okay, I'll move it to little to this side, and also I'll take the snapshot because I want to. Okay, copy and paste it here. Oh, what happened? Okay, no problem. G. So the friction will work on this side. So that means friction will work on this side opposite. So that means friction is in here, in this direction, right? So what is friction equals to? This friction is F is equal to mu R. What is R equals to? What is R equals to? R is R, we have to find out R plus, if we manage these powers, r plus p sine of 30. So r plus p sine of 30 is equal to 1.2 cos of 40 degree, right? So sine of 30 is 0.5. So r plus 0.5 p is equal to 1.2 into cos of 40. That would be, okay, 0.9192. Okay, R is equal to 0.9192 minus 0.5 P. So this is the normal contact force, right? Then what we are going to do? But we need to find out the friction. So limiting friction, that F limiting, that is equal to mu R. So mu is 0.32 into, that would be 0.9192 minus 0.5 P. So if you multiply inside, F limiting will be 0.294114 minus 0. Let me calculate. Okay, 0.16 P. So you got the friction equal to this one. Okay, so there would be two situations in which the particle, this power is enough that it is to move. It is at the point that it is going to move upwards, but it is not moving, but it is at the position that it, if a little more force is involved, increase, it will move upwards. And you know that friction, works in the opposite direction. So if the friction is working in this direction, so what will happen in the first situation? I'll write down the first situation. Now, first situation will be that P cos of 30, this 1.2 sine of 40 plus F, sorry, F is equal to P cos of 30 will uh, take the horizontal components, this one. So sum of this is equal to this one. Okay, so P cos of 30 is equal to 1.2 sine of 40 plus frictional force, this one. This friction force is this one. So we'll substitute this value. So this is 0.29414 minus 0.16 P. So if you bring 0.16 P to the other side, this one, because this is P is here on this side and this is constant value, so this one will become P cos of 30. Cos of 30 is 0.866 P plus 0.16 P. And if you do it calculation on the right side, 1.2 sine of 40 plus 0.29414 is equal to, that would be equal to 1.0655. And if you add them up, then this will become 1.026 P is equal to 1.0655 and P is equal to 1.038 Newton. This is rounded to three significant figures as required. This will be the P when in the first condition. Okay, in the second condition, I'll let you understand the second condition. Okay, okay. In the second condition, when the object is to, this is force is too less that it is to move downwards. It is at the point that if a little bit more is lesser, it will to move downwards. That means this is the motion direction of motion now. So obviously the limiting frictional force will work in the opposite direction. So in this one, in this part where we, okay, let me copy it down first and then and paste it to the other page. Okay, now this will become, now the friction, as I told you, this is to move downwards. Frictional force will work on this side. Okay, that means friction will be working in this direction, F limiting. Now the second situation will be 1.2 sine of 40 degree is equal to P cos of 30 plus friction, and 1.2 sine of 40, I'm tired, 40 is equal to P cos of 30, which is you can say 0.866 P, 0.866 plus friction is this one, 0.29414, 0.29414, and minus 0.16p. So minus 0.16p. So we'll bring this constant to this side to subtract. So this will become 1.2 into sine of 40 is 0.7713, and we'll bring 0.29 to this side, 414, and 0.866 minus 0.16, that will be 0.706p, and p is equal to, if you divide it, that will be 0.676 Newton, correct to three significant figures. So you got the p, which is, so what is the set of values of p? That would be, p could be greater than or equal to 0.676 Newton and less than equal to, this is 1.04 Newton. Okay, hope you have understood the concept. Thank you very much. Okay, let me highlight this. Okay, you got the set of values of P, which are between these limits, this limit. Okay, the next question is question number 6, which is the last question of this paper. So in this question, they are saying, we'll read the question first. The diagram shows a fixed block with a horizontal top surface, and a surface which is inclined at an angle of theta degree to the horizontal. Sine theta is given to this one, so we'll highlight this one. Sine theta is equal to this. If you do the theta is equal to sine inverse 3 over 5, so you can find out theta, what is theta equals to. Okay, later we'll find out. Okay, let me find out. This will become 36.9 degree. So this is 36.9 degree. Okay, a particle A of mass 0.3 kg. So this is 0.3 kg, and this is, okay, A mass of A is 0.3 kg to the horizontal surface and is attached to one end of a light inextensible string. The string passes over a smooth pulley, a P fixed at the edge of the block. The other end of the ring string is attached to a particle B of mass 1.5 kg. So we'll write down this is 1.5 kg mass. Okay, on a sloping surface of the block, the system is released from rest. So this is really important because the initial velocities were zeros. The string is taut. Given that the block is smooth, find the acceleration of particle A and the tension in the string. So we have to find out the two things. We have to find out the tension, acceleration of the particle A and the tension in the string. Okay, so in this one, first one, this will be coming downwards because this is the heavier object and this is the lighter object. Obviously, the motion will be in this direction. So motion direction will be this one, right? Okay, so this will be the driving force. Driving force will be if you draw the horizontal component and vertical component. So this is mg 15 Newton and this is 90-degree, sorry, actually the place is some lesser. Okay, so this is the vertical component, this is theta, and this is mg is equal to 15 Newton. So 15 cos of theta, and this is 15 sine of theta. Okay, the driving force will be 15 sine of theta, and the tension will be the tension in the cable will be the resistance. In this one, tension will work to this side. It will be the direction of motion, and it's mg, its weight. There will be no resistance as the box is smooth. So for particle A, Fd driving force minus resistance force is equal to net force. Tension in the cable is the driving force, and there is no resistance force as the box is smooth. So this will be 0.3 is the mass. So T is equal to 0.3 A. So you got the first simultaneous equation. You can highlight this as this one. Okay, for B, for the object B, there is Fd minus driving force minus resistance force is equal to force net Ma. So mg sine of theta, this one is the 15 sine of theta. 15 sine of theta is the resistance, is the driving force minus resistance force is the tension in the cable, that is resistance resisting the motion in the opposite direction. Okay, then this is equal to its 1.5 into A. Acceleration, as they are attached by the same string, so the tension and the acceleration will be the same. So you can say that this is 15 into sine theta is 3 over 5. So minus T is equal to 1.5 A. So substitute T, this will become 9 minus 0.3 A is equal to 1.5 A. So 9 is equal to 1.5 A plus 0.3 A. This will become A is equal to 9 over 1.8. So A is equal to 5 meter per second square. You got the acceleration in the cable, and then we'll find out the tension. You know that tension from here, tension is equal to 0.3A, 0.3A. So tension is equal to 0.3 into 5, and that will be tension is equal to 1.5 Newton. Okay, hope you have enjoyed the paper is completed. It was the last question. Hope you have enjoyed the lesson, and inshallah will come up with the with some other paper. Uh, mm, do subscribe my channel if you haven't understood something. Okay, Allah Hafiz.